Way Anova. Analysis of variance is a method of testing the equality of three or more population means by analyzing sample variance. Way Anova. The Way Anova is used to compare three or more population means when there is a one factor of interest. Requirements. The populations have distributions that are approximately normal. The populations have the same variance. The samples are simple random samples of quantitative data. The samples are independent of each other. The different samples are from populations that are categorized in only one way. Way Anova is a hypothesis test. There are 7 steps for a hypothesis test. Example: a professor at a local university believes there is a relationship between head size and the major of a student's in her biostatistic classes. She takes a random sample of 20 students from each of the 3 classes and records their major and head circumference. The data are shown in the following table. Step 1. State the null hypothesis. Mean 1 equals mean 2 equals mean 3 equals mean 4. Step 2. State the alternative hypothesis. At least one mean is different. Step 3. State the level of significance. The level of significance is 0.05. Step 4. State the test statistic. F equals the variance between samples over the variance within samples. The test statistic follows the F distribution, which has 2 degrees of freedom, one for the numerator and one for the denominator. The calculations for the test statistic are complicated, so a software program is generally used for the calculations. We will be using Microsoft Excel for this example. Step 5. Calculate. The calculations are done in Microsoft Excel using the Data Analysis Toolpack. Enter the data into the spreadsheet as shown here. Click on Data, and the Data Analysis Toolpack button is on the right. When you click on the button, a dialog box appears. Choose ANOVA one factor. Then another dialog box appears. Input range is where the data is in the table. Be sure to put a check in the box for labels in the first row, and then pick a cell for the results to be displayed in. We need to be able to interpret these results. Step 6. Statistical conclusion. The summary output from Excel gives the observed test statistic as well as the critical value. The null hypothesis is rejected if the observed test statistic is greater than the critical value. Since F equals 0.816124 and is less than 2.769431, which is the F critical value, then we fail to reject the null hypothesis. Step 7. Experimental conclusion. There is not sufficient evidence to indicate that there is a statistically significant difference between the mean head size of different majors in the biostatistics classes of this professor at a level of significance of 0.05.